Okay, we're going to go ahead and get started here. Today is October 11th, 2025. It's 12:06 here in Spokane, Washington. My name is Aaron Murakami with emediapress.com, and we have Eric Dollard live on a call today, and some of the other EPD crew members. We got Connor Fisher on the line, and also Haka says. Um, Justin Miller is not able to make it onto the call. And then there was somebody else at the recent Tonopah episode, Yari Karvinen. He helped a lot with a lot of organization, cleaning in the shipping container and organizing parts, that kind of thing. He's not on the call either. But late August, early September, we were all down in Tonopah working with Eric on some different projects. And the main topic on this call will be actually two videos that were recently posted on my blog, and you can see it on the YouTube channel. One is the open wire line demo, which was actually recorded back in 2017. I got a copy of that from Justin after the Tonopah job last month, and he also gave me a zip file with about 45 pictures or so. We don't have to go through every single one, but Eric can kind of narrate, so you can kind of learn a little bit more about what's in that video. And then also there's a ground reception video where me, Eric, and Yari were out there in Tonopah, out there in the desert where the lines are, and Eric is hooking his car up to a ground system, which massively increased the reception of radio stations all the way across his entire AM radio. And when I did the same thing with my Toyota Tundra with the modern day AM radio without a real type of receiving coil in it, it almost didn't do anything. But the power line noise came through pretty good. So um, before we get into and then after, I'll share a couple of the videos that we will be putting out on the Tonopah work episode, and then Connor and Haka says can jump in and kind of talk about what's going to be happening next, which is related to some of the projects that we were working on. Um, the Energy Science and Technology Conference, the goal is I'm going to be starting this again next year. It's going to be sometime between the second half of June to the first half of September. It will not be on 4th of July weekend like it normally has been. And there's a couple other dates that won't work. I'll work around Steve Ellswick's Tesla conference, and there's somebody who helps me with the videos. He has a date. He's not able to do it, but I'll be posting that, and I'm putting together a speaker agenda right now. Most likely there's going to be there'll probably be close to 20 presenters, and there'll probably be, a little over 20 presentations over a 5-day event, Wednesday through Sunday, just like we have done in the past, X amount of energy science technology conferences. Eric will be presenting on the Alexanderson aerial, which is the long line that we have on the land out there behind the shop in Tonopah that's being used for the above ground earth signal reception right now. Eric has presented on some related topics to that, relating to the Alexanderson network in Bolinas, California, right there by the RCA Marconi station. And if Eric is able to come up to Spokane and present live, that's great. And if not, then we may stream his presentation in live. I'll be doing a few presentations, and then I'll be posting the speaker agenda here pretty soon. So just keep an eye out on emediapress.com. And if you go emediapress.com/energy times, that's the free newsletter where most of the main announcements go out. Also, right now, the Bedini RPX sideband generators, I have 120 of these being assembled right now. If you happen to be watching and have an order pending, as soon as I get those on my hand, those are going to be shipped out. I just helped them with supervising some of the testing on those just to make sure that was going well. And so I hope sometime by the end of next week, I have some in my hand so I can fulfill all the back orders. And then there's 2 or 3 MWOs ready to ship right now, whether that's the PC board antennas or the copper ring antennas, and all the parts are being accumulated right now to make 20 to 21 more MWOs, which should be completed by the end of December. So if you want one, it's a good idea to either get one of the first two or the two that's available right now, or pre-order and prepay for one so that you're at the top of the list. So as soon as those are ready by the end of the year, then those will be shipped. EPD Laboratories, Inc. is a 501c3 nonprofit organization registered in Nevada, and it operates solely on your donations. And so if you go to ericpdollar.com/donate, this is the best way to be able to help the organization so we can, move these projects forward that we're going to be talking about. And you can either donate by PayPal, you can do a recurring payment or a one-time donation, or you can write a check or send a money order to the address you see in Spokane, Washington. And I just sign those checks and send them down to the Bank of Nevada. And that's what supports the organization, all the overhead for the building, buying parts for projects. It helps with some travel and lodging and food expenses for some of us to go down there and spend time to kind of crank out these projects. And so I guess other than that, do you have anything you want to start off with, Eric, or we can just kind of talk about the open wire line demo? Jump
Yeah,
right into
let's just go to that first, get started.
that. Okay. So on my YouTube channel, youtube.com/Aaron Murakami, that'll forward to this at Aaron Murakami 13. If you click on the videos link, you can kind of see everything posted in chronological order. This is from 4 days ago. It says open wire line demo. This is a video I got from Justin. This is done back in May 2017, I think is when Justin said he believes this was done. 16-minute video. And do you want to kind of give us a synopsis of what this demo is actually showing, Eric?
Yeah, so this is when we have one antenna finished in the Mojave Desert, about 250 miles away from here, in an extremely remote location. It's a rather remarkable facility. You got 5 miles of underground and about I would say 2 miles of overground, one of which is turned into the antenna. And so right now what we're doing is testing the performance of this arrangement to see what signals we can get and what strength they are and how much power line interference there is and what the level of the earth signals are coming in from this arrangement, even though this is a time of day where earth signals are not normally receivable. They're coming in loud and clear here, and the power line interference is acceptable in this area. So unfortunately, it doesn't seem like we have any pictures of the antenna structure.
Let me see if they're in a slideshow, Eric.
Yeah, well, I know they're somewhere.
Let's see. I have instead of doing it here, I'll just do this preview pane here. Can you see that picture about a campfire, Eric?
No, just got a blank white. I don't know. I got all that YouTube stuff, so I don't know.
Haka says, can you give me a thumbs up if you see that campfire picture? Thumbs up, thumbs down.
No,
Okay,
you're on the YouTube screen right now.
is it? Okay, here, let me stop share, and then I thought it would just share whatever I'm opening up, but
I think it depends if you're sharing the app versus the monitor.
is that showing?
There you go.
Yeah.
Okay.
Yeah,
So
that antenna is covered in the electrodynamic seismic forecasting video. So this is Justin working on the antenna structure right now. It was quite dilapidated when we first got there. There were smashed poles and dangling wires, and I think we cleaned up. I've been working on this project for probably about 20 years, a little bit at a time by myself. And it was a massive cleanup operation. There was about 20 miles of wire all knotted up, strewn all over the desert, and broken insulators. And but there's one little section that that was revivable. So this is the effort to do that. So these are the finished cross arm installations. The pole pair's already up. We're putting in the dead end arms for the carrier pairs on the outside. And that has to be pretty heavily reinforced because that's a heavy dead end load, about 1,500, 1,800 pounds. This is one of the intermediate poles. Now, but go back to that one. The other one, you went, yeah, this is the same antenna structure as we have here with the carrier pairs on the outside, the pole pair in the middle. The only thing that's different here is we have a 5-mile section of 11 pair telephone cable, most of which is underground to use as an underground antenna. This is an absolutely priceless facility, but we can't put it on the air, even though it's all workable, until somebody comes up with the money to get lease in the old TD2 microwave site that this ultimately connects to. So that's a pretty serious deal to negotiate a lease like that and make sure that there's enough money in the bank to keep the lease paid on a monthly basis for a reasonable period of time. So basically, this whole project is just kind of on hold, if not abandoned.
Okay.
But a lot was learned from what was going on, and the work we did on it, it will last another 30 years.
Is this for a ground rod?
Yeah, this is the grounding out in this type of geography is really difficult because the ground is mostly nothing but rock. And the only way to get a ground rod in, and even then you got to be lucky, is you got to get it right into the root of one of these creosote bushes. And those roots go down about 100 feet. So they become a remarkably effective ground, even though it's in a desert area where there isn't much groundwater. Okay, that's one transposition section on that arrangement. Pictures are shrunk again, but at least they're visible.
Yeah, it's doing its own zoom in and zoom out.
Okay. Yeah, if you get them bigger, then you can kind of see. So it'll be noticed that, by some that that this is the exact same arrangement, cross arm arrangement as we have here. The only difference is the addition of the cable.
And that's what a lot of people don't know, is that there's actually a second location besides Tonopah in an undisclosed location that has been kind of put together and sitting there for a long time. And so most of the efforts on video and photographs for a long time have pretty much exclusively been in Tonopah.
Yeah, this project was a massive and expensive effort to pull off. And what's interesting about it is this antenna is actually a companion to the one here. So the whole idea is to have two electrically identical antennas spaced about 250 miles apart, and then you can get a bearing on where the electrodynamic seismic signals are coming from. So here, go back to that one. Expand it if you can.
So you're talking about like spatially locating rather than just knowing
Stereo.
something will happen.
Yeah, stereo.
Yeah.
So this is if you go back to you went ahead that one. So this is where we're separating the antenna part of the 2-mile section of the line to the transmission part of the line, which terminates at the the old AT&T microwave facility, which is now it's being leased out by some communication syndicate to, whoever can pay the lease and meet the security qualifications and what have you to put equipment in there. I don't know how much it would cost. It'd probably be rather expensive, and we'd have to have at least 5 years, if not optimally 10 years of money in the bank account to pay for it, which is considerable. But what's also considerable is how much money's been spent on this so far. I'd say between the two aerial ground structures, this one in the video here and the one that's in Tonopah, we're looking at $50,000. This is not cheap. There's the labor, the time, the materials. It was $8,000 for the wire for the antenna in Tonopah. Fortunately, this one, the wire was already up and the cross arms are already up. So I think you can kind of see the idea of, watching Justin work here, that there's a lot of engineering involved here and a lot of skill required to do all this type of stuff. And this thing was in such bad shape when we got it that all the poles were bent over because the guys had corroded loose, and it was like a massive chiropractic effort. We had to take up about 5,000 pounds of load to straighten this whole thing up and then back it a little further so everything could kind of settle in and the poles would be straight again and the insulator pins wouldn't be torquing the cross arms. And but now it's done. So this is the video that's on YouTube now of the signals thing. This is what it's connected to. That's what I wanted to show. One of these cross arm repairs. Oh, no, not that one, but there's another one. It was such a dangerous, ungodly mess of unresolved forces and wires ready to fly through space and all of that, that when I showed Justin all this and said that I had a plan to rebuild it, but we did it.
Okay, I think that's the whole slideshow. Let
Yeah.
me see. So on emediapress.com, if you click on blog, you can kind of scroll down and see the blog posts sequentially. So there's the 2017 May open wire line demo. And then you want to go right into the ground reception one, Eric?
Yeah.
Okay. So the ground reception video, that's also on the YouTube page here. The more recent one, September 1st, ground radio reception, EPD Laboratories, Inc. And so that's the video where we were connecting the ground system to Eric's radio in his 1980 Toyota Corolla, and then onto the my 2007 Toyota Tundra truck radio. And the differences were, not night and day differences. It worked with Eric's and it didn't do anything on mine. Just heard a lot of power line noise on my radio, but every single space on Eric's radio was occupied with something broadcasting once he had that set up. Do you want to kind of go over that, Eric?
Yeah. Yeah, that one down there on the bottom corner, it would be the best because it kind of shows what wires are going where.
Okay. Well, I can just go through all of them like a
Okay.
slideshow too.
Okay.
And
So-
for the camera setting was kind of dark. There's something going on with the camera setting I couldn't quite figure out. So everything is kind of dark a little bit, even though it was nice and bright. So that
Yeah.
it's kind of muted a little bit. But anyway, we can start here.
Okay, so this this basically is one end of the Tonopah antenna structure. The other end connects to the cable TV shack. This is kind of the,
Here, let me take a glance real quick at the thumbnails. Are you looking at the thumbnails right now that I'm
well,
looking at?
I'm looking at the square you have expanded.
Okay. Can you see the picture with Yari there?
Yeah,
Oh, you do? Okay, good.
yeah,
Are you looking at the lines right now? Going out to the
yeah,
shack?
yeah, there we go.
Okay, so it's working.
Yeah, so you'll notice that the crossarm and insulator configuration is identical from the other one in the Mojave Desert. So that's kind of, even though it's not optimum, it's the easiest way to go about making a multi-use antenna. And I think I gave a pretty intense theoretical and what have you description of this thing in one of the prior YouTube videos.
And you can, and everybody can see, this is the shack up here on the hill, so
Yeah.
it's quite a distance that these things span.
So what's up right now has 9,600 feet of wire connected to about 2,500 feet of wire going to the cable TV shack. And most of that wire I have to roll up out in the Mojave Desert in 3,000 or 4,000 foot sections, which were kind of heavy to deal with. But over the course of a decade, I harvested a lot of abandoned material in the Mojave Desert, which was instrumental in putting all this together here so that we don't have to waste the new copper wire on situations that don't need it.
So
So
what's this roll of wire you're
so
unreeling?
what this is there's this is the telephone wire, you know, like used to go to real telephones. You had red, green, yellow, and black. And so the red and green, they connect to the transmission pair, the pole pair, which is 4,800 feet long. And then the yellow wire connects to the ground rods, and the black wire connects to the buried linear conductor for the lightning arrestor ground. So this is where the conductors terminate on the pole. So the outside pairs are not upright now. We have all the wire for it. It would be, it's 5 miles of wire, but we don't have the money for somebody with a bucket truck to come put it up. It's just too hairy to work on the outside arms. But what did it change on me?
So you got the wire coming up to your antenna here?
Yeah. So what was done? Yeah, there we go. So just keep it here for a while.
Okay.
So what I did some months back was because I go out here usually daily to hike and to inspect the line. And I decided, well, let's hook this thing to the AM radio in my car and see what kind of fantastic reception there is. And so the first thing I did was put a big battery clip on the black wire and the yellow wire, which is the earth connection, and connected it to the hull of the car at the point at which the AM radio antenna emerges from the corner fender there. And the AM radio just exploded to life without any coupling at all to the actual AM radio antenna. And to me, that's the final proof that the Tesla idea of telluric communications is an absolute reality. And that, as I've pointed out all along, is the AM, well, this is a real car. We can't speak about cars made today, but a real car with a real AM radio, which has a Tesla coil in it, because the antenna is such a small fraction of a wavelength, it's no more than an aerial capacitance. The AM radio in the car does not receive electromagnetically, no matter what Einstein tells you or his followers. It receives through the body of the car into the ground. And as long as the aerial is a free space capacitor, then it will do that. And if the coil is resonant with that aerial structure, the capacitor, then it becomes a Tesla transformer, and the body of the car is the way to connect it to the ground. So that's what I'm doing here. And then in the video, it shows the increase in reception. In fact, it's interesting is when I have my hand on the clip and I become energized with the what's coming out of the earth, I don't even have to touch it to the car. Just walking up to the car makes the AM radio come to life. And then what I did was paralleled the two conductors of the pole pair that twisted the red and green together and capacitively coupled them to the elevated capacity or aerial of the AM car radio antenna, and then that basically filled in the reception, and stations were coming in from all over. Unfortunately, no stations follow the FCC rules anymore about identifying themselves and giving their call letters and location every 15 minutes because there is no law anymore. So you can just do whatever you want. Maybe you've kind of noticed that in your surroundings. That's the world we live in now. So kind of trash the AM band, and you can't tell what you're listening to anymore. But usually, if you listen to AM radio a lot like I do, and this setup in the car, even by itself has about a 500-mile range. You kind of get to know the AM band. In fact, people like Steve McGreevy, he can identify every single AM radio station in the entire United States. So there are ways to still kind of know where it's at. So that's once I discovered this, then I definitely wanted to video this and demonstrate it. So that's what we did here. And then the idea occurred well, let's try it on Aaron's truck, because I noticed back in the days, RCA days, when I used to have to work with Pacific Gas and Electric, when we were looking for incipient arcing on insulators and bushings on the lines to the substation for the RCA station, I could track them with the radio in the car as you see it, but the expensive equipment and the newer vehicles that Pacific Gas and Electric had could not find the arcing. It kind of blew their minds. So all these things have convinced me that the newer stuff ultimately doesn't work. And then we proved it with Aaron's truck, in that the AM radio was very effective at picking up power line interference, even though on this setup, the power line interference was next to nothing, even with all that wire up in the air from the same coordinates as the power line. Yet the little antenna on Aaron's truck picked up the power line interference loud and clear, but refused to receive any of the AM stations. So I think this is a testament to what's actually going on with radio and Tesla's ideas and digital versus real equipment. In fact, the non-functionabilities of the digital world was really a massive complication in this effort to get the signals on the air that we said we were going to get on the air. Is the digital world just wouldn't cooperate. And so we're back to square one on that, but maybe Connor and I might be able to get some of it going this time around. But basically, digital doesn't work. So we demonstrated that with Aaron's truck. The digital radio did not work at all. And the regular radio in my car worked loud and clear. So whatever naysayer wants to argue with that, well, maybe you go need to be beating your pots and pans outside of an ice facility.
Okay. Let's see. So that's the ground radio. So in the coming up later, are we back on the regular camera view? Is that what you're seeing?
Yeah,
Okay. So I'm just looking at some folders here. So the next videos that will be coming out on all these episodes will be the amplifiers. So the amplifier video and pictures is that Eric has developed an audio amp. It was kind of reviewed in the musical seismograph presentation. I think that was also about 2017. And there's been different pictures of it posted where this is been sitting on Eric's bench for years, and it's picking up. You can tap your foot on the ground and you can see the scope jumping and that kind of stuff. But this is a proprietary amplifier which amplifies based on transconductance rather than a regular voltage gain amplifier. And this is going to be eventually in the shack to amplify the earth signals coming off of those lines. And there's a simplified version of the amplifier which is going to be made available commercially. I'm getting some transformers and chokes custom made by Hammond, and we have another workaround for one of the other chokes we need. And as soon as we have those in our hands, Eric will wire them up, and I'll probably head down to Tonopah to help test those out. That'll be the first proof of concept model, and then we will be making available a handful of these for sale. They're going to be very expensive. And after the initial round, then we'll open it up after to higher volume number of units once it kind of gets designed more for the end consumer. Because right now it's kind of in a raw, rugged rack mount panel form. It can probably be put into about two 19-inch rack mount units on a little server rack. So after the proof of concept is working, we might do maybe 5 of those or so just to make that style available. Then after that, it'll be tweaked for the general consumer. We are going to file patent applications for it because it is so unique and novel that there's no audio company in the world, in the history of audio over the last century, who has ever had anything that works like this. And so it's truly going to be the first truly seriously novel audio amplifier that has ever been commercially available. And this has been basically developed by Eric over the years. And that now in the video and the pictures and stuff, we're not going to show anything proprietary, but you can at least see kind of a general idea of what we're working on. There's going to be a video coming out. There's a storage container in back of the shop with a lot of parts. I mean, it's basically an electronics store inside of there. And Yari did a lot of work organizing that to make it easy for Eric to be able to find parts, easier to, strip different equipment and make those parts available for a lot of these projects. And Yari was helping with some of the stuff out on the lines with Connor and Justin. There's going to be some pictures and videos on the shack itself with the transmitter that Hawkes has put together to digitally receive and transmit these. And we're trying to have these stream online. And the test was successful. It worked. And so we're going to be looking at getting that, back and running. Also, there's the telluric transmission with the beacon. That'll be another video coming out. And currently that's not online right now, but it will be. Connor and Hawkes can give some feedback on where we're going with that here in a bit. And then at the end of the work episode, Eric, myself, and Justin, we have a video where we just kind of went over a summary of everything, and that'll be coming out too. Um, so any other comments on either one of those videos or anything I mentioned, Eric, or we can have Connor and Haka says jump in and kind of talk about the work, what's happening next with those, and then maybe we can open up for questions or something.
Well, I can kind of give the lineup of what are the next things here that need to be done. So when Connor comes out here, there's a lot of things that need to be done, unfortunately. I don't know what kind of struggles we're going to have with getting the Earth signals on the internet. We'll see if that works or not. The important thing right now is to try to get the telluric beacon transmitter on the air. That's very high priority. And then the other priority is to get the TCS Navy transmitter to start making the necessary steps to get that modified to replace the China box transmitter, which doesn't belong to me anyway. So that's got to come out, and it uses the digital and it soaks up so much electricity. It's almost ridiculous, and it's nearly impossible to control, where the TCS transmitter not only is an architectural masterpiece, but is very easy to control and extremely reliable and rugged, and does not use as much electricity. So that will probably be in the 60-watt range, and then we have to I don't know, with the weather coming up, if I'm going to be able to keep this thing on the air on a daily basis. The other thing is, I don't know, is the special capacitor that we have to make to couple the aerial to the transformer is probably not up to snuff for being out in the weather. So I'm probably going to have to pull that off and make sure that it can stand working in the pouring rain. So that's one major project. So getting the shack on the air and getting the telluric platform on the air, that's kind of the two things that we have to do. The other thing is all the batteries that we have for the various voltages in the shack for the equipment in there, the 12 volts for the toy radios and equipment, and the plus or minus 24 volts for the solid state electronics, and 120 volts for the vacuum tubes. Those are all the voltages that we have to have there. Right now, there's no one available or money available to have anybody put the panels up and put all the regulators together and all that kind of stuff. So what we definitely have to do, we cannot slide on it, is we have to take all the batteries and we have to put them in their own location or on a bench and get them all hooked up the way that they'll be in the shack, and then have a small power supply, keep them on a floating charge, because it might be quite some time before we get those solar panels and the whole solar thing. It looks like could be over a year or so. So the batteries have to be put on standby. And then they'll also be used for the amplifier projects, because all of this stuff basically runs on 128 or 120 volts DC and either 24 or 48 volts DC. So that's what the amplifier research will be running on, those batteries, to test them out and what have you. So, and there's probably something I left out. There's a million other things that can be done, but that's the primary focus of when Connor gets out here. We'll see how much of that we can get done in the time allotted.
Yeah, so we're thinking that we'll be able to have the telluric test beacon on the air, signals from the antenna online within the next couple weeks, presumably even within the next week. But and it is all sort of experimental. We're gonna have to be running tests while we're doing it, and tuning things in. So be interfacing with Hawk says and some other people are helping out in terms of doing like spectrum analysis off the signals from the antenna, try to, isolate sources of interference and noise and such. So there's going to be a lot going on, but hopefully those things will be on the air and online pretty soon here. So
Yeah. I could paraphrase a little bit of it. So the two issues we were trying to handle last episode, for my side, it was the receiving signals from the long line and getting them retransmitted out to the internet, and then the telluric test platform to have a 24/7 beacon that was operating. As with any experiment, both of them had a couple of bugs on it. The telluric platform, the beacon, I think it turned out to be more of a software issue. When you try to make something a little more complicated than it should be, so it ends up doing nothing. Anybody that installed too many apps on their phone or on their computer can realize when you have a little bit too much, the whole thing grinds to a halt. I think I fixed that by basically stripping away all the fat and extra, we'll say, features we didn't need. So it's back to it being a very simple beacon. Tested out, and it was working okay on the bench here. That's already sent to Connor. He should be able to install that in his next trip. The other issue was getting the data logger. You guys probably got some emails for the live test feeds a few weeks ago when that was on the air. Same thing. I was largely successful because we did end up getting a connection out, getting cell service, getting an actual internet connection, getting reliable signals. The only problem that we had during that was there was more interference than expected coming from certain sources, the way it was configured. I was set up for testing and minimizing all of the RF noise and things that were coming from the confuser and whatnot. But I had neglected basically between the data logger, which is basically a little Raspberry Pi computer, and the Wi-Fi, the MiFi cell phone, basically a cell phone with just a data plan. The wire that went from the data logger to the silly phone link was communicating on 100 megabit Ethernet, and it turns out the 100 megabit was close enough to the 145 megacycles VHF ham radio band that when the thing was online, the signals were creating so much stray RF that it was basically drowning out the repeater station that was also up in the shack. So between a combination of tweaking that down to a different band, adding some metal shielding on the cabling, and adding a whole bunch of other metal shielding on the data logger after we finish that episode, the goal is to have it sent back out, have Connor hopefully install it, get it running, and hopefully it will be good for 24/7 reception and access now. So hope to see how far that gets. Knowing Murphy's Law, there might be a couple other bugs to work out, but hopefully those are more aesthetic than functional. But that's all I have for that. The only thing that I've been working on lately since returning that is the issues getting the long lines data logger infrastructure going. Is all of the effort and difficulty is basically on the structural design phase. So what I've been working on lately is a more I'll say mass-produced version of the same thing, a similar type of system that can receive electrostatic signals instead of a long line antenna signals and retransmit those onto the net as well. So ideally, not only would we have Eric station online, but we would, in the relatively near future, have multiple stations online that you can both pick from and synchronize with, and well, I'll say the more data, the better, because we might be more likely to pick up noise and isolate where certain sources are coming from. But I think that's about all I got for now. I hope, that makes some sense.
Why don't you point out how much fun it was to tune the Tesla transformer to the area? To describe how, we had to come up with this novel capacitor and how many times you had to move it back and forth. Just so people get an idea that this just isn't, tightening a couple of bolts down.
Well, the original, so our telluric test platform, you know, the Tesla coil that sits outside that's designed to transmit power into the ground. What we
I
had
think
been using for the
Aaron
for
can
the
get a
first,
picture of it. Yeah. But yeah, keep going.
but what we had been using up until that point was basically a variable capacitor. A lot, yeah, that's the one. There was a variable capacitor on the top of that to tune the system, all you had to do is, you know, rotate the capacitor a quarter turn or eighth of a turn or a fraction of an inch. Uh, because we wanted to bring this as an outside permanent structure, we couldn't really use that kind of capacitor. So instead, it was replaced with, you can barely see a black wire on the top.
There you can see
That
the piece of
you can see the
coax.
very
Yeah.
top of it. But basically, instead of having a variable capacitor, we had to go with a fixed capacitor. And the I guess easiest or hardest solution, depending on your perspective, is to essentially use a certain length of coax cable to act as a fixed capacitor. So, yeah, you can see it above the rings on the coil. There's a black cable that leads up. So this is essentially a capacitor with the inner shield or the inner lead being one terminal and the outer shield being the other terminal leading to the aerial. So we need that to bring the frequency down to a specific range of 1999 kilocycles. So it's legal for ham radio to transmit and, you know, within our operations. The problem is that black little line has to be tuned very, very precisely. It took me about a day going up and down the platform, back and forth, cutting little pieces at a time, like cutting an eighth of an inch of shielding, then another eighth, and another eighth, and another eighth, till we got it right down into that 1999 kilocycle we needed. And then, as soon as we had that up, we had to add one more called a sense line to the right-hand side of that pole, not pictured, but adding that one little sense line, because everything in the whole vicinity turns out being part of the circuit, that brought the frequency down to another 20 kilocycles. So it kind of ruined my work. So have to bring it down again. Have to bring it down again, cut a little bit more off, and, you know, restart the same process. But I think long term, what we'll try and end up doing is probably have some different sections. I don't know. There's got to be some way to improve that a little bit, to add that some little micro tuning besides moving the wires in and out. But it turned out even adding like a foot of extra wire could throw the tuning off by maybe 10 kilocycles. And the frequencies and efficiencies we're trying to run at, it's tricky. Put it that way.
Tedious is the right.
Tedious. That's the word. Yeah.
Yeah, tedious.
Simple and easy are not always the same thing.
Well, it takes you know, an unusual level of perseverance. So
The good news, you only have to do it
definitely
once.
demonstrated that.
Yeah, it was about a day and
breaking something.
day and a half to get that all tuned in, and then we added one lead and it threw it all off. But it still transmits. It's just a little bit off. So instead of 80, 100 watts, it's more like 20 to 40 for now. But maybe if Connor has time, he might have some time to help trim that down and bring us back into square. But hope that makes some sense. Anyone have questions on that? Yes, it is quite the sight. We finally started putting that back up outside. There's, of course, it's just so weird and unique. You start getting the gawkers and the people driving by that slow down or stop or low to see this massive structure. This what the heck sitting off in the corner of someone's yard.
Every time I go to the store now, the checkout ladies, what's that thing outside your building?
There was one guy that would walk by. It's like, hey, are you going to talk to aliens?
Oh, wait! What I always do, I go, yeah, Mars is going to invade next week. So get ready.
Yeah.
They don't know what to say to that. So you can't believe how many questions I get. What are those antennas on your car for? And I have a special answer, for each person, unique that goes along with their personality and attitude.
Well, there's like the 6-hour answer that's the full technical lecture, and then there's the
Right.
2-sentence answer to satisfy someone's curiosity.
So I guess
So,
that kind of covers what we want to show then.
yeah, I'll just show this one picture real quick. So somebody, let's see. Are you seeing a picture
So
of that transmitter, that beacon?
there you go.
So that's the frequency. So the point of this is, besides just being experimental, is that for any radio enthusiasts out there, you can make your own ground system to receive out of, tune it to this frequency and let's see how far, people can actually pick this up, So it's kind of a challenge, of sorts.
So I guess I should summarize the last couple years of experiments. When the platform first got finished, we were sending out about 100 watts, and we did some short range tests, having Steve McGreevy and them drive out to see how far they could receive the signal. It turns out they were getting good reception with less than 5 watts, which was as low as we could go, out to like 20, 30 miles. The following episode, we had done another test with Steve about 160 miles away, I believe, but testing throughout different times of the day and different times of the night. It only worked in certain time frames, but we were able to get up to over 150 miles with less than 5 watts on that specific system. So it got some pretty crazy, amazing results. This was also one where Eric and Justin had driven off to, I think, 50 or 100 miles away to do the same types of reception during the day, which was pretty impressive. So the problem is we only set these up for temporary missions on each of these episodes we're working on. Now to have this set up as a long-term beacon station, it's conceivable that we can get more than hundreds of miles away, depending on what people are listening in, what kind of ground reception or what kind of reception system they have. So who knows? We might be thousands of miles away with this type of system. We just don't know yet. But having the 24/7 beacon,
Yeah, that's the whole purpose, is to, for ham radio guys and what have you, to start doing experiments to see who can pick this thing up. But then we still got a long ways to go here to get this thing all tuned up, right,
oh yeah,
what have you. It's got to be right on frequency. So right now, the way that we would have to operate it optimally would be to tune away from the frequency that we had chosen and find
the
out
new
which
number for
one is
now.
fully resonant. But that invalidates the automatic Morse code, which would then give the wrong frequency.
Hmm.
That's one of the drawbacks of the software, and that kind of stuff. Is the basic rule of thumb here, ultimately, if possible, is the engineering dictate is there's two no-nos. There's two verbatims. One is things that are made in China. Two, the presence of software. So the way that these beacons are best done, and the way they did it out at RCA, is they have a code wheel and a cam switch,
Nice.
and the thing just turns year after year, decade after decade, half a century. Never a problem. No software.
Yeah, the problem with the software on the test that we did was, how it had the different switches between different modes, like 1, 2, 3,
Yeah.
4. The way the software had set up is that it was having a problem understanding which one of those numbers it was on, because whenever it would transmit or flip the switch, the debounce would cause it to wig out a little bit. And I
Oh,
think
yeah.
that was what was throwing us off, because it wasn't on the right setup. It was giving like the ICOM.
Ultimately, the way that it will have to be done here is with relays or
Yeah.
transistor flip-flops. So basically, you have a time generator. So what I have is the interrupters that make the busy signal and the ring signal and what have you. In the yesteryear telephone exchanges, they put out an endless series of pulses, and then you have a set of relays that works those pulses into dots and dashes, and then you have a sequence generator that then configures what comes out of the relays to turn into your basic Morse code identifier. But obviously, with something like that, you can't get into a whole page of text. It's
Right.
just going to be your call letters and and the things that go with the call letters, and that's it. As far as the code wheel goes, that one's real easy because you just saw some notches in a plywood disc and put a micro switch on it, and ultimately, by law, all I have to do is transmit my call letters. I don't need any other text. But the route I think I'm going to go is what I had for the automatic telegraph at Landers, which was there's a ham radio computer program, and it's an adapter box that connects to the computer, and then you can type in whatever you want, and it'll put it out to a relay and then key the transmitter that way. So that's really the way it should be here.
Yeah.
Because I can't be dependent on external factors or what have you. It's got to be something that works reliably enough and works for me. So, but right
Well,
now we got what we got.
You want to remove any unnecessary complexity. And what I ended up doing, metaphorically speaking, is even though it's still software, I ripped out, 70% that handled all of this logic interface selection
Well,
stuff. So
the
it's
one main problem with digital, and it's an absolute nightmare in this type of work, is it appears to be that all electronic controllers, computers, whatever it is that comes from China, is set up to deliberately jam radio frequencies. I've determined this with one of the answers I give. What are those antennas for in your car? And I say so that I can sense the electromagnetic environment around me, like an insect detects the electrostatic field around its body. And I can drive around and I hear the most god-awful noises coming out of things, deliberate jamming to the CB radio, complete wipeout of the entire AM broadcast band. Right now, there's a business 2 doors away that is literally transmitting kilowatts of radar pulses back into the power line, which this modern YY connected power system is lighting up the whole town. And so consequently, we can't receive anything at all here in the building, which kind of defeats the whole purpose of what we're trying to do. And the net sum of it has basically induced so many harmonics and so much interference into the power grid that we have megawatt rivers of this gangrene energy flowing about 5 miles in the ground underneath here throughout the Nevada desert. And it has completely wiped out any possibility of end-to-end ground reception, which was like one of the main projects for here. But then the power company went YY, and all of a sudden, that was no more.
Should we open up for questions, Eric?
Can we get a picture of the TCS?
Yeah, let me bring it up.
Yeah, there we go. This is the transmitter and receiver that is ultimately going to be operating the telluric transmitter. It's amazing that there's still a lot of these radios available. This was like one of my first transmitters when I was a child. The transmitter is very well suited for doing this Tesla research because it goes way down low in frequency. In fact, this is a very popular transmitter for bootleg AM radio stations. I did that when I was in the Navy because these transmitters were rather plentiful back then, and it goes down into the broadcast band. And you can get away with stuff on a Navy base, but you might not want to try doing that kind of stuff in another area. But I know people that do have TCSs and they have a little AM broadcast for their neighborhood.
Can you sit a little closer to your laptop? I think the sound get cut down a little bit.
So these things are very low tech. They're good for about output of about 100 watts. The receiver is not remarkable, but nevertheless it performs well. They look nice. With its original power supply, they'll operate off of a 12-volt DC power system, even though we're going to use an AC powered power supply to generate the voltages for this, because the voltages in the original setup are quite low, and you cannot get the rated output power of the transmitter tubes. So we got to go from 400 volts to 600 volts for the higher voltage tubes, and from 225 to 300 volt for the lower voltage tubes. I successfully, when I was in high school, ran the transmitter with up to 1,000 volts on the plates of the tubes, and nothing was damaged. And many of my my Tesla experimental setups in Bolinas use this TCS12 transfer. This is a TCS8, but most of them are, no, this one's a TCS12. This was the exciter for all of my early Tesla cosmic induction generator experiments in Bolinas. So this is the really perfect unit for doing Tesla research, and there's no way you can burn it out, and there's nothing digital, so you don't have to worry about it generating any interference or playing little games with you behind your back. It's very inert. It was basically designed in early World War II for the PT boats, the plywood attack boats that the Navy used against submarines and other landing crafts like the LCS and similar vessels. All had TCS transmitters and receivers in them. And remarkably, there's still 2 or 3 of them on eBay to this day. They're not cheap. I spent $1,000 for 2 transceivers. One had most of the power supply, dynamotor power supply, and most of the cables and what have you. So that's the final unit for here.
Okay. Should we go ahead and open up, see if anybody has any questions on?
By all
Yeah,
means.
I think we're ready.
Okay. If anybody has a question, there's a React option in the app, or whatever, however you're logging in here, and just click on raise hand, and if you've got a question, can unmute and then ask.
There's a question in the chat here, just
Let me
popped up.
open the chat. Genco Run. Okay. Good evening, Eric. If we disregard electron theory as the means of power transfer, how exactly do diodes work?
Well, you need electrons for diodes because they're not electrical, they're electronic. So there's a big difference between electrical and electronic. Electrical basically shuns the electrons, but electronics embraces the electrons. That's why electronics and electrical are like a square peg in a round hole. There's a lot of problems with putting electronics into electrical systems and attempting to have them behave electrically. And that's part of what generates all of this hideous interference and harmonics on the power line, particularly that modern practices, in order to skimp on the cost of production, deletes a lot of very important components, and that just causes a lot of havoc. So transistors, vacuum tubes, diodes, arc discharges, those things are all basically electronic or corpuscular, to use the words of J.J. Thomson, where things like power lines, transformers, inductance coils, condensers, and what have you are electrical because they involve the electrical field in the ether. So basically, electronics has to destroy electricity in order to operate. a good example of that, if you take let's take an aluminum reduction plant, which is one of the biggest users of electricity. I think there's a remains of one in Spokane,
Kaiser.
and it's typically fed by like a 345 kV power line. These things are massive. They're millions of amps at like 2 or 3 volts, and what they do is they electrolyze molten aluminum ore, aluminum oxide, and they generate enough heat to keep the medium molten so they can perform the electronics. But that electricity in has an output, which is bars of aluminum and oxygen gas. So the heat generated, in other words, the amount of energy destroyed and not turned into something useful, is probably about 10 or 15%. Now let's take an electronics facility called a data center. These things are becoming of outrageous proportions. They might have a 345 kV power line going into them. They're going to be low voltage, not as low as 2 or 3 volts, but they're going to be in the 12-volt range. The amperage is going to be insane, and the rectifiers are all going to be massive harmonic generators. And digital and electronics does not produce a usable physical output. So every kilowatt that goes in is a kilowatt of heat coming out. So what has been generated, this is kind of a joke when you consider the global warming issue, is these data centers are going to be massive space heaters of absolutely unprecedented proportions. So you have the aluminum reduction plant, which for the most part is electrical, which basically power in, usable output. You have electronics, digital, power in, only heat, waste comes out. So that kind of shows you, like we did with the new car radio and the old car radio, the difference between electrical and electronics. And it's important to keep those distinctions in mind.
Okay. Is that James, or would that be Jaime? As a question.
Jamie?
The frequency is 1.999 megacycle.
Yeah.
And what is the turns and diameter of coil? What are those basic details?
Oh, I don't know right off the top of my head, but the coil is about 2.5.
Yeah, it's like
diameter.
25.5 inches or something.
Okay.
Roughly
represent
1 to 1,
pictures
so it'll
here.
be about the same.
Yeah, it's a symmetrical.
Take about 100 feet of 1/4-inch copper wire.
Yeah, I think we'd have to look at the picture, but there's
100 or 125.
there's something like 15 turns.
It's like, yeah, 14, what I'm getting the count on.
Okay.
Is there any issue in at some point in the near future giving out the exact specs of that if anybody wants to replicate that exact
I think Griffin already did that, but
for that exact one?
well, I mean, at least that material was prepared. So,
Okay.
I mean, there's no reason not to do that. It's just somebody has to do it.
Okay.
Maybe that's something when Connor's here. Well, actually, it's something that should be drawn up like blueprints.
We'll say it doesn't have to be an exact 1-to-1 match. The critical part is to match the resonant frequency, the quarter wave resonance. So it could be a little bit bigger or smaller or whatever, as long as it matched in that category. I don't know where I'm going with that.
Wasn't it Bruce Gavin did a replica of it already? Is that correct? Or
Bruce Gavin has another one. It's quite a bit smaller, and I believe it's on a plastic frame. But the coil is only about half of the equation. It might be relatively easy to wind the coil, but the harder part is getting a very low impedance ground for this. You can't just like drive a single ground rod and expect it to perform very well. If you do want to do you might actually get some reception signals. We're not sure how far the range is yet, but to do like higher power reception and probably around the world stuff, we probably need like an AM radio station type ground, or maybe a like receive from a boat or something that has a really nice surface area to a ground plane.
A lot of houses built in the 50s in my area have like these oil tanks under the ground.
Mm.
So
Well,
But
that's
it's
what
up for
we're using
experiment.
here. Is here we have a 35,000 gallon tank filled with water buried in the ground, and needless to say, that's one hell of a ground. And then the one that we have in an underground water stream out there at that terminal pole where my car's parked, and what that was connected to, that was a very effective ground also, which consisted, I believe, of 8 ground rods and quite a bit of 2-gauge bare aluminum buried, I think, about maybe a 1.5 feet into the ground, and chemically treated with magnesium sulfate to improve its conductive characteristics. That worked out quite well. The bigger the coil and the heavier the turns, the lower impedance and heavier demand on a good, a really high ground admittance. But a smaller coil wound with finer wire does not have that need. And then coupling, basically refracting the transmitter into that circuit is an extremely tedious arrangement. None of this stuff can just be calculated right off. That's what makes it difficult. You have to arrive. You can get in the ballpark, but both Griffin and myself have, and I believe other people have come up with, basic engineering formulations that come out pretty close.
Mm-hmm.
But there's nothing exact here. Is the circuit constant approach and the speed of light, that doesn't work at all, and so it's not easy. And then the fine tuning, well, you already gave testimony to that episode.
Well, it's like wind an extra 5% of wire and then trim as needed, because you don't know how much the frame is going to affect it, how much the wire, anything in your surroundings can affect the tuning. It is good though to actually wind a couple test coils in that vicinity and then play around with, because, well, one, you might be able to do little experiments like light fluorescent bulbs with just a little signal generator, and also when you play with the reception and the tuning, you get an idea or an actual feel of how much different things in the environment will affect the circuit and the tuning. Like when you're tuning the coil and you move your hand, a foot, when the coil is off in the distance and you see that frequency change on an oscilloscope or on a field strength meter, it gives you an intuitive, hands-on feel of what that difference is.
Your body is part of the tuner.
Yeah, it's crazy to feel that firsthand, and it's really simple too. It's just an air core, open frame 1-to-1 coil.
Okay. Question from Bon Jovi. Let's see. Could some of those units creating heat be cooled in electronic fluorinated liquid? I guess you're talking about like the data centers and.
Well, that's heat to heat.
You know what they use right now to cool a lot of these data centers is they use evaporative cooling.
But the thing is, it's still heat.
Well, let me summarize some of this. So the data centers and the internet, basically the electronic internet infrastructure nowadays is estimated to be over 10% of the power grid is used to run computers and the internet and the infrastructure. These data centers can, use power larger than small cities. These are like moderate sized cities. These are sections where there will be a room that has, 30 racks by 30 racks. It'll have racks and racks of equipment, and this will be one room, and there will be 100 rooms in a center like this, like crazy megawatts of power. What a lot of these places use for cooling, because normally AC units and other systems are not efficient, or they're too costly. What they'll use evaporative cooling. The problem is they use a lot of fresh water, because you literally need like high quality filtered tap water that they evaporate and just vent into the atmosphere to help cool these systems. So not only are they using an extraordinary amount of power, but they're also using a whole lot of water. People don't really, I don't have the formulas in front of me, but it's a substantial cost. They've drained aquifers based on this.
Well, the other problem with that is when the water evaporates, it leaves its minerals behind.
I think they use some kind of filtering and things like that, but it's like a bunch of fresh water that just gets vented off into space to cool
Well,
these
the minerals are
electronic
going to have to
systems.
go somewhere. I know about the maintenance of those cooling towers because RCA used those for the water cooled vacuum tubes.
I'm sure there's
And
some
they get
industrial infrastructure.
real scabby. Okay.
Mhm.
Same thing with these swamp coolers. Oh boy, those things can just turn into a mineral mess. So it's not it's still no usable output.
Yeah, it's all waste, but not only power, but also water.
So we could remove the minerals out of the water with our electrical water process for only 2% of what it would cost a distiller. So 98% reduction in power, and that's an absolute thing because
But
we can do that. I wish the temperature was higher because then you could run our Tesla turbine on it. You know, we need about 300 to 350 degrees Fahrenheit, and we can produce, over a kilowatt with our small little system, which nobody in the world is doing or has ever shown. But I think those data centers are only in the 100 something degree range, right?
yeah, if only these chips ran hotter, they could at least boil water and start turning them into steam plants or something. Like make it
The
useful.
bottom line with these things, and that's what really, makes this whole climate stuff a hoax, is all that humidity and all that heat. Okay. I mean, a 345 kV power line can really crank out a lot of that. You're talking about 60 megawatts. 60 megawatts is like 60 locomotives, going full power up the Tehachapi grade. What is that going to do to the weather? It's not sustainable.
Mm-hmm.
And the fact that we're going to have to go back to nuclear power to run these things, well, I thought that was all bad too. Isn't it amazing how what was bad yesterday is good today? First, the livestock run to the east, and then they stampede to the west, and then you stampede them to the north, and they fly over the cliff. That's how the Indians did it.
If there was a cold enough sink, like if the condenser was, because it's all about the differential. Because I mean, we're on our closed loop Tesla turbine system. We pull a vacuum on it. So if the condenser was in a cold enough spot, we could run that turbine on 100 something degrees. But that's seasonal. I know a lot of the data farms are here in Washington because it's some of the cheapest electricity in the world. Like north of Spokane, you go up towards the border up by Medellin Falls and stuff, and some of these data farms are getting bulk electricity at like 1.5 to 2 cents per kilowatt hour and stuff.
Mm-hmm.
So it's like nothing. It's insignificant. And the Bitcoin farms and all that kind of stuff. And then with the AI server farms, those are going to dwarf the data centers, and that's just going to be beyond ludicrous what the power usage on those are going to be. But
Well, what I like to point out is what was the central theme of the movie The Matrix? Do you remember what the central theme was? Is
human batteries.
Humans exist to run the computers.
Human batteries.
humans become the source of electricity for the computer. Well, it's a terminal situation, so
Yeah.
it just makes you just feel so great to be alive, doesn't it? To know
Wonderful.
that in 5 years.
So
Anything that's not sustainable won't be.
So,
We have
Lauren's, just hold on a second. Let me just
Mhm.
get these two text questions and then,
There's a couple
we'll-
more chat questions too.
yeah, we'll get to your question. Ametsis 42, if counter space is the space between the division marks of a ruler, how is ground supposed to be counter space? If there are longitudinal waves transmitted through counter space, not space, with no entropic time, should there be no waste heat?
Well, those are all speculative questions. So it's kind of hard to say how this is flowing through the ground. I'm not going to commit myself to anything, but from the counter space standpoint, the Tesla currents are not current that involve flow of electrons, but they're a current in the electrostatic lines of force within the atoms and molecules themselves, and not the movement of so-called particles or corpuscles, as J.J. Thomson called them. So I was able to translate J.J. Thomson's work with incredible difficulty and extract the actual dimensions of these so-called longitudinal currents, whether they generate heat and or magnetic fields. That would have to be determined by experiment. At this point, I'm not trying to theorize on why the signal goes from one place to another or all that right now. I'm just more interested in the engineering of making it work.
But there was the old cosmic induction generator experiment, what, 14 years ago or something like that, where you graphed out X amount of RF watts going into the middle and disappearing with no signs of heat.
Yeah, that's an example of where is the energy going? It's going into, obviously it's going into another space, or it's being destroyed. People don't like that phrase because of the law of conservation of energy. So if we stick to the law of the conservation of energy, or as Heaviside preferred to call it, the law of energy continuity. In other words, you follow energy from one point to another until eventually it turns into heat, which is the destruction of energy. Then that energy that the transmitter is cranking out, that's not heating up the coils, it's not lighting anything up, it's not sending out radio waves, the energy is going somewhere. So if that energy is going somewhere, then one could infer from that that energy can be taken from that somewhere.
Yeah,
So
direct corollary. If it's possible to synthesize energy, or if we believe in
it's the law of reciprocity.
Yeah.
You know, if you can pour water into a bottle, you should be able to pour it out of the bottle.
Mm-hmm.
And that was in one of the that was in John Polakowski's presentation, I think, at one of the first conferences or something. But those graphs and everything on the power going in between those two coils on that cosmic induction generator experiment is, I think the presentation is called Cosmic Induction Generator. That's on emediapress.com, and that was from roughly around about the second or third conference, 2013 or 2014, something like that. But that was all presented on.
Well, everyone's interested in the free energy and making power out of nowhere, but the thing is, energy destruction is just as impossible. And if it's easier to engineer, then it would be interesting to demonstrate.
That's it. Is the law of conservation of energy says energy cannot be created or destroyed.
But I think
if you destroy it.
That's all that actually does happen. I think the language needs to be straightened out, because there is no such thing as energy. Energy doesn't exist as a thing. It's the activity of the dissipation of potential. So when you organize the potential, which is organizing and polarizing the ether, when it goes to a low spot or lower potential, any resistance that it hits on the way dissipates that back into equilibrium. And that right there is the creation of energy and the destruction of energy simultaneously, because energy is the work being done. Energy is not a thing. It's, like Eric says, is the destruction of energy. So, you got 1 watt second, for example, of actual work, or actually heat produced. That is the creation of energy and the destruction of energy simultaneously. So the law of conservation of energy, in fact, doesn't even exist, because you're not conserving anything. All you're doing is you're organizing potential, you dissipate it through resistance. There's the manifestation of energy, and then it dissipates right back into equilibrium. So when you recreate a new potential difference or a dipole to polarize and break the symmetry of the ether to have a high spot in order to let it travel back to a low spot. Any potential it hits or any resistance it hits on the way is going to dissipate it again. So, but it's not the same stuff being used over and over. It's a freshly created cycle of polarizing the ether, dissipating it, repolarizing, redissipating. So nothing is conserved because you don't have to conserve anything. You're just creating it on the fly, on the spot, fresh on every new generated cycle. In my opinion.
Yeah, but it's all speculative. I mean, we can kind of go on, forever, but the bottom line is the transmitter is indicating, that it's putting out power because, the plate current on the tube indicates that a lot of power is going into the tubes, that generate the radio frequencies that run the Tesla transformer, but the tubes aren't get overheating, the coils aren't overheating. In fact, I've even seen this, with saturable reactors and transformers and what have you. Is the damn thing will show 400 or 500 watts on a watt meter made for, not being fooled by reactive power and all those kinds of things. But
A true watt meter.
the transformer's not smoking. So where's the energy gone? And ever since the first days that I started with this Tesla transformer thing, even though I didn't know they were Tesla transformers, I somehow, came up with this stuff all on my own with what RCA provided me with when I was in high school. That's where I discovered this stuff in experiments. And you always knew when the coil was in full resonance because it consumed the full output of the transmitter, which was like around 3,000 watts. But nothing was getting hot and nothing was being radiated. So
Like you have a 3 kilowatt space heater, but there's no heat coming out.
there's no heat coming out. So who knows? It's more experimentation and analysis and what have you, but that stuff all takes time and money. And right now, I'm only concerning myself with the practical end of this. And the theory is I'm kind of done with that right now after writing about 5,000 pages of material on it.
Okay. Genko Run, does the fact that capacitance increases with decreasing space support the possibility that counter space is itself a spatially inverse dimension where distance does not actually exist?
That's pretty close to the way I look at it, but it's not distance anymore. It's closeness. It's the inverse of distance.
You there, Lorenz? I see you're unmuted. Still working on it. Yeah, I think that space is determined by the ether, and if there is no ether, then that's the true counter space. And if you have a polarization between two antenna, like between the MWO antenna, and you're polarizing that space, the reason it can go instantaneous to the other side is because that electric line of force is actually deflecting and repelling the ether around it, which is a source of inertia. Like when an object accelerates, the ether, it's encountering more ether per unit at a time, which means there's more ether going in through the matter to impart an electrostatic push on the protons that make up the mass. So that slows down and resists its acceleration. So if you have a high voltage electric field, if you want to call it that, and it's deflecting the ether around it, that means there's no inertia to hold it back. So it's instantaneously from here to here without taking time to get there. So there's no velocity. And it's also not going through space because that which makes up space, which would be the ether, is actually deflected around it. And so that's how it's moving through counter space, at least the way that I see it.
Well, one thing I'll point out is space and time are metrical dimensions and have no physical existence. So it's not a good idea to load too much on to the phrase space and the phrase time because they're just terms of measurement, and they don't really have any actual substance dimensions to them, like matter or ether or induction, or they're just the measurement means. So with, this modernistic physics and all the gobbledygook that they, spew out, our heads has become filled with all of these. We're trying to put all these definitions on things that aren't really applicable. So at this point in my life, at age 73, I'm tending just to disregard all of that and just go with what I know, and deal with just the engineering world. And when the opportunity presents itself to actually do some experiments or what have you, then that can be theorized upon.
Yeah. And the whole dimension thing is screwed up and it's Newton's fault.
Oh,
They-
yeah,
They,
it's a mess.
Descartes did the XY and then Newton added the Z, but it was no longer a tool for him that was supposed to represent reality. The XYZ, and then Einstein and Minkowski, they cemented it. And that's the root of all the BS when it comes to how people look at the dimensions and stuff. I know we've talked about that. That's something I want to explore more.
Yeah, the whole
writing
whole
on the
dimensional
history.
system, at least in the electrical world, is completely trashed by the physicists.
Well,
Completely trashed.
okay, Josh, unmuting you. Go ahead and introduce yourself, where you're from, and go ahead and ask your question.
Hi, I'm Josh. I'm calling in from Germany. Can you hear me?
Yeah, it's a little bit muffled. If you can get
Muffled?
closer to the mic or speak up a little bit.
Yeah, can you turn this up? Do you know
I don't.
audio settings? Hold on, I'm gonna turn it up a little bit if I can.
Yeah,
Sounds
that's
over
okay.
here.
Yeah,
Yeah,
just
that's
get
okay.
as close as you can to the mic.
Okay. Yeah, I got a couple questions for Eric. First was, what type of radio did you have, or do you have in your Corolla? Because I assume it's like an 80s style transistor radio, right? It's nothing super special where you're getting the ground reception from.
Yeah, it's a stock Toyota AM radio. There's other radios in the car. There's also a VHF scanning receiver that I use for, like, weather stations. And when I'm out, living in my car in the wilderness, I always keep it tuned to the fire frequencies so that I know if it's time to bail, stuff like that. And of course, the CB radio. CB radio is a very important piece of equipment in my car. Not so much because of the CB, because nobody talks anymore because of digital. The CB is dead, except for the yelpers, which come from the southeastern United States, of people that hoot and holler and what have you into their microphones. And the kilowatt level is very useful for me, measuring the intensity of ionization in the ionosphere. And then I know what the solar activity is by what's called SKIP. So that is one of the electromagnetic sensing items in my car. The AM radio also serves as a sensing item for various power line interferences and jamming and what have you. And then the big radio on the rack is the HF rig, which is the Marine Corps PRC 47. That is that's for listening to HF signals and also transmitting in the ham bands. But like CB, there's nobody that really can do Morse code anymore, other than for contests or something. You can't have hour-long conversations at 30 words a minute with anybody anymore, like it was in the good old days at KPH there in Bolinas. So I mainly use that for the WWV, even though they have suspended most of their data reports because of digital. And when I'm out and around in the wilderness, then I tune into whatever interesting shortwave stations. I'm looking for crazy music from Boogie Land or wherever. I find it entertaining to listen to that in my car when the propagation's good. And also the PRC 47 gives me, again, an idea of what the ionosphere is doing by seeing, when known located transmitters come in, like WWVH in Hawaii versus WWV in Fort Collins versus BPM in China, which all transmit on 10 megacycles. I can get a pretty complete picture of what the ionosphere is doing on that, basically, that whole quadrant of the Earth. And then I have the low band VHF, which was used extensively by all of us in Bolinas to communicate. That is another Marine Corps radio. It's the receiver R442, and that one is, for the most part, now that there's nobody left to talk to, they're all gone and dead. From the Bolinas days, that one is kept tuned to the City of Los Angeles Department of Water and Power, because they have extensive power line right-of-ways all throughout all the places that I live in my car. And they have the associated repeater stations for the guys that are out there working on this stuff. So that way I can get kind of an idea of what a major electrical utility is up to, or what kind of problems they're having. And I was pretty heavily involved with DWP when I was in Owens Valley, so that's become kind of a permanent fixture in the car also. So then there's a slot behind the CB radio where the Stephen McGreevy device goes in, and that connects to the CB antenna and gives me remarkable Earth signal reception. So when I'm in the Earth signal reception mode, then basically the PRC 47, the AM car radio, and the Steve McGreevy device, all on different bands from ULF all the way up to HF, I get a stereo representation of what the Earth's electrical activity is inside my car. And that's quite fascinating in itself. And that's how I can tell if there's going to be a major earthquake somewhere on the Earth, about 12 to 18 hours before it happens. That gives me a very strong indication of an impending earthquake of like 7 magnitude or greater.
That actually brings me to my next question. So you finished the Tonopah line. Well, not finished, but it's operational now.
It's not finished. It's just that the pole pair is up.
It's operational though, correct?
It's operational in part.
It's a demonstration stage.
It's operational in part. In other words, it's taken to a level where now it can actually provide a useful service, but there's a lot more to go.
Yeah, no, I understand that.
Yeah.
But have you been able to view any signals either on an oscilloscope or any other type of equipment that have indicated that there's an earthquake coming? Because there's been quite a few earthquakes in the last year. I was wondering if you've had any.
It hasn't been on because we're having all these complications with the digital stuff. So,
Hey,
and then the other thing is it's not at its full embodiment point now. So the fidelity is not what it could be, because we still have to build an input amplifier and an output amplifier that's got a automatic gain control. We have to put the Audimax or the CBS Volumax peak limiter in, and all of those things, and the power line null signal. And when that point is reached, whenever that may be, I don't know. It's not looking good that we can get much farther than we have now, because there's no more funds and no more money coming in. But at that point, it will give a quality of reception of Earth signals that is unprecedented. But right now, it's going to be good enough. It's better than just using an AM radio in your car, because it gets right down into the root ultra low frequency signals. And before there's any major earthquake, about the day before, usually at sunset, the thing will go wild. There's no doubt about that.
So
So
Eric,
now, go
I
ahead.
just want to jump in with this website real quick. So this website's under construction. The normal website is ericpdollard.com. This is epdlabs.org. This link right here, seismic streaming, this is where we actually did the live streaming test from those lines on those poles, which went into the shack. And Hawka says digital transmitter sent it out, and then it was streaming live right here. This is just a pre-recorded sound loop. Can you actually hear that, or
No.
You probably can't because it's the
okay?
Zoom will
It's as if
automatically tweak it. Yeah.
Yeah,
yeah.
remember we tried that with the music and it wouldn't play
Yeah.
it. Yeah.
So there was one point I played a video on one of these calls or whatever, and it actually came right through. And so I don't know, but in any case, this is where it's going to be. So eventually, um, when it gets live again, it'll be available here, and then we'll have a membership thing, and there'll be like maybe two tiers. One is for free. You can listen to the signals. There'll be a certain amount of stuff. And for a paid subscription, you'll have access to a lot more data. Even if it's the free one, you're still going to have to register for an account and log in, but it's free. And that'll be on, some kind of membership page. And you'll be going to whatever membership page is associated with your account, based on whether you have the free account or you have a paid subscription. And so this is the next part on this right now, is to get it restreaming live. And once we get that worked out where that's, as flawless as it can get, then it'll just advance from there.
Yep.
But this is where it's going to be, is on this epdlabs.org.
Yeah.
Okay.
Basically, until this point, it was getting all of the infrastructure in place. So now we're just on that edge where we can start doing long-term, high quality recordings and analysis.
And that's the aerial, correct?
Yeah.
Yes.
So with the Tesla, what do you call it? The telluric test platform.
Hmm?
You're putting out 100 watts. Do you know what's been received? You said you did a couple tests. Do you know what the received power was or the signal level was?
No,
It
it didn't have a survey meter. It just had to go on, the relative strength.
Okay.
But
So
and it was only those short-term tests that we had performed mostly last year. The best it was over 150 mile, less than 5 watts, but it was not throughout the entire day. It was only at a certain window.
what was remarkable is we went out in my car at noon, which is the worst time for these kind of frequencies. And with only the 8-foot CB whip on the snout of the car, and I think you were putting about 200 watts in.
That was about right. Yeah.
The point where we reached the minimum discernible signal was 55 miles away. And closer than that, the signal strength came up quite remarkably. In fact, the signal strength was basically full strength on the PRC 47 for the first 20 or 30 miles. And then it started to fall off pretty fast. So that's pretty good for an 8-foot antenna and not having a Tesla coil in the car. Now, I figure if I had a Tesla coil in the car, in other words, if the AM radio was, that configuration was tuned to the frequency we're using, which was again, around the 2 megacycle range, the reception probably would be phenomenal. And if this thing was done full Navy style, which would be 1,500 watts, and everything was all tuned up and, and what have you, which it's not now, it's anybody's guess as to what this will do. So we're just starting to scratch the surface on this, but the fact that Steve McGreevy picked this signal up over there in Lone Pine at 2 o'clock in the afternoon, full strength, when I think you said you dialed the power down to 5 watts.
It was early evening, so I think it was right around sunset when we got that best reception. So it was around sunset, and yeah, we started at the 200 watts, and he picked it up clear. We kept turning it down lower and lower, 150, 100 watts, and he was still picking it up. And it wasn't until we got to like the 5 to 15 watt range that it was starting to fade out on his side.
Yeah, when I talked to him about that, he said he'd never heard a 180-meter signal that sounded the way that did. So it's definitely going to work. It's too bad that it's happening so late, because this is originally why RCA had engaged me back in 1973, was they were desperate for a new method of ship-to-shore transmission so they could remain competitive to the satellite ship-to-shore systems, which were very uneconomical back then. And unfortunately, it took me about 20 years to figure it out and to begin to install it at the RCA station. And then the story of my life unfolded one more time, is just when we were ready to actually do a ship-to-shore test, the station was shut down, and Commonweal and Greenpeace overran the place, and that was the end of everything.
I'm glad you kept going, because it's pretty interesting stuff. I've learned a lot listening to you over the last 10 or 15 years. So keep it
Yeah,
up.
I think I might be the only person left on the planet that knows any of this stuff.
I think there's a few of us that are trying to catch up, but you kind of leave us in the dust.
Well, you got a long ways to catch up. You got to remember that I started this in 1958.
Yeah. And when you were like 6 years old, I did it when I was in my 20s.
Yeah, and on top of that, I had like the full support of Pacific Gas and Electric, Bell Telephone, Radio Corporation of America, United States Navy, LA Department of Water and Power. I mean, those things don't come around anymore.
No.
Nobody is basically, the whole electrical technology now is like a creature with no head, and it's just flopping about. And that's the way the power grid's being rewired, and that's the way it's all going. Nothing works anymore. No one knows how it works. No one wants to know how it works, and no one's interested, and it's over. So all I can do right now is, ultimately, this keeps me entertained before I finally fall in the grave, and that's if that's all I get out of it, that's fine. But I'm trying to get the material out. Like I say, I have several thousand pages of finished material, which is completed. The principal efforts of Steinmetz and Heaviside and J.J. Thompson and Arthur Kennelly and what have you. But there's no interest in funding that. So it's another dead horse.
It doesn't need to be transcribed short term. We can just put out the ebooks with the scans, and people just have to, they can like it or they don't. But
Yeah, actually, I was thinking, because the stuff, is written well and all that, why not put it out in an Amazon book? Do you have to have it?
yeah, I would wait until it's transcribed, but the ebooks is easy enough to put those into ebooks.
Yeah.
But also, last month, that was the first time I actually had copies of any of this stuff. So there's nothing I could do about it before then.
Well,
And
I think you got copies of the earlier Steinmetz, Kennelly, and what have you stuff.
yeah, you already scanned like 1,000 pages of stuff.
But this was a long time ago. I think you actually have those out in ebooks, don't you?
There's so many titles and so many papers, it's kind of a blur. But I'd have to know exactly which ones. But yeah, there's a lot of there's a lot of material, and there's a lot more coming. But after the scans, because I want to play around with, using Grok, some of the OCR stuff. It's massively advanced from what OCR used to be. And it's just going to, be an experiment to see how fast and easy it can be transcribed, and put into a book. that would be good for a paperback, but short term, they can be put into ebooks with the
Well,
scans.
I'm cranking it out every day. So,
So,
you know, about 4 hours a day. I'm still producing material. Right now, I'm writing the book on three-phase power because that's another lost start that's going awry. And
mhm.
nobody has a clue of what any of it means anymore, how to hook it up right. So I'm writing a very elementary book that is incredibly easy to understand, even though it's a very mathematical and complicated subject. Um, I'm getting, you know, quite a kick out of doing it. Of, you know, all the years of my life, I first started studying this stuff when it was in high school, out of my father's books, and what I learned out at RCA about three-phase power, and of course later its connection to the music of Bach, which is very analogous. Those were the two primary interests of my life, and now all of that stuff is finally coming together in very finished form, and it's satisfying to see how simple all of this complicated and esoteric polyphase mathematics and what have you can be reduced down to just simple junior high school mathematics equations. So I find that enjoyable. And then I learn from it. So that's the one thing that I can keep going without any money and without any assistance other than making sure that utility bills are paid and what have you. So that's what I do on a daily basis.
Okay. Any final question, Josh? We're on 2 hours. We can take maybe one or two more questions and we'll go ahead and wrap it up.
Nope, none more from me. Thanks for your time, Eric. Thanks for answering my questions.
Yeah, you're welcome.
Thanks, Josh. So as you know, EPD Laboratories, Inc. is a 501c3 nonprofit corporation that survives based on your donations. And if you go to ericpdollar.com, hit this donate link right here and scroll down and you click this button, you can it'll open up a screen to be able to donate through PayPal, one-time donation, or you can click this link, make it a monthly donation, you know, $5 a month, 50, 100, the more the better. These projects do cost money. It can, the costs add up pretty quick. Also to deal with all the, you know, property taxes, insurance, utility bills, you know, electric, phone, internet bill, all these type of ongoing expenses, and then, you know, to get parts and to help with the crew get down there and to work on some of these projects that you're learning about in some of these, you know, videos that we're showing. It does take money. I'd say short term, if we could raise $10,000 real quick, we could probably squeeze a couple episodes out of that with several people down there in Tonopah accelerating and moving this forward, rather than having to wait. I know that Connor is going to be going down there here real quick. I know I'm going to be going down. Usually I pay my own expenses and everything. But you know, anything helps. I got to go down to work on the amplifiers with Eric and with you know, Justin and Haka says and Connor to be able to take these projects to the next level. The shack, we got to finish up the solar panels and the batteries and all that stuff's already made, but there's some different components and stuff that have to be put together to integrate that into the whole system in the shack. And there's some other projects. And so if anybody knows anybody who wants to support this, that can put in, you know, a couple $1,000s at a pop. Ideally, I think if we can raise about 10,000 over the next month or two, then we can probably have a late winter episode with a few of the crew members down there cranking this along. So we can just kind of accelerating it while, you know, while the fire's hot, let's keep it cooking.
Yeah,
So
we're on a roll. We got to keep it moving, but
yeah,
you know, with the cost of labor and each one of these episodes
yeah.
is nominally $5,000.
And so And then if you want to send a check, money order, cashier's check, this is the address here in Spokane. I am the what is it? Secretary and treasurer for EPD Labs. So I sign those checks, mail it down to the bank in Nevada, and that's pretty much what funds everything. And so any help is appreciated, no matter how big, how small. Those donations make these things possible, and like you see, we're sharing just about, you know, as much as we can in these on these calls and the videos and the slideshows, and then of course when the presentations come out. And again, I'm looking at between the second half of June to the first half of September, with the exception of 4th of July weekend, Steve Ellswick's conference in Albuquerque, which I think is about in the middle of August. And then there's one other date I have to check. The conference will be during that time. And so some of those presentations, I'm sure, are going to, you know, have some of the elements dealing with a lot of the projects going on down in Tonopah. Doesn't look like Lorenz was able to get his audio working. So any final comments, Eric, before we wrap it up? Or?
No, I think we've exhausted the subject.
Okay. Anybody listening to this, please, you know, share this on Facebook or you know, your own mailing lists. You know, if you're watching this, you probably know other people interested in this. So please share what we're doing. Encourage people to, you know, pitch in with some of the donations so we can, you know, because the more money that's available, the more we can do in a shorter period of time and keep this going. And that's really important. So,
Lawrence actually did have a question. He typed a question.
oh, he did type one in.
Yeah. How come William
I see.
R. Line have such a low opinion of the harmonics approach?
I don't.
William R. Line, harmonics
Yeah,
approach.
I know about him. But
He has that occult ether physics book, and he actually spoke a couple times at the conference and stuff. But anyway, go ahead.
yeah, the thing that I'll give him credit for is it was interesting. Is a good friend of mine. We were the rat crew in Bolinas back then. That's how I made money living in my car in the bushes. Was you show up at 4 o'clock in the morning and you scrape the floors and clean the sinks and do all that kind of stuff, and then about 5 o'clock you hang out with your buddies that do the same thing and you have coffee, and 6 o'clock the place is open and the rats scurry back into the bushes. So my friend Joe comes in with this book, occult ether physics or something like that, with some crazy picture of Einstein or some spaceship or something, and he puts it in front of me and he goes, you gotta read this book. And this guy's saying the exact same stuff you're saying about J.J. Thomson. And I go, come on, Joe, you know how I feel about that space loony stuff. Oh, no, he's just saying the same thing you are. And I go, no, Joe, I'm not into it. He finally, well, let's look inside, and I've seen, well, there's some interesting stuff, and that book gave me a remarkable renewal in interest of the work of J.J. Thomson, and a much better idea of where he was coming from. So that's one thing I'll say about William Line, is he really kicked me into a second wave of J.J. Thomson's study. So those particular books where they might be kind of a little borderline, or kind of like
Borderlands, if you will,
is as far as for the layman, they're really good because they give you kind of the general perspective, even though the details might be completely backwards. So I think for the layman, the books are somewhat helpful, but you know, you might have to kind of take some of it with a grain of salt.
And you can still get occult ether physics on Amazon. I don't know if his son is still publishing them new or whatever, but there's used copies, and I mean, you can find the PDF online and stuff. But yeah, William R. Line, occult ether physics. That's the name of the book.
Another good one is Jerry Vasilato's Secrets of Cold War Technology.
That's a hard paperback to get. When you find it, it's usually many hundreds of dollars anymore. You know, I bought it from Adventures Unlimited or whatever many years ago for $20 or whatever it is. But that PDF is online too. You know, if you look for it, that Secrets of Cold War Technology by Jerry Vassilatos, who's also at one time, he was with Borderlands too, wasn't he?
Yeah, I actually was the one that inspired him to write that book.
Okay. And he was like a high school science teacher in New York or something
high
like that.
school science teacher, and then what was interesting in turn, he had revealed in his Grill Compendium information about the Alexanderson antenna that was much more detailed and more accurate than what I had learned from RCA, and that had a massive impact on me. It was like an apocalyptic revelation of oh my God, I never knew that this is how far it went. And then that's when I went full bore on Alexanderson antenna research, which basically I regard as, you know, being on the same level as Tesla's telluric transmission system. It is actually a telluric transmission system, and it's the only radio system developed that is not in conflict with Tesla's patents. It's truly novel. And it's a result of the joint efforts of Charles Steinmetz and Ernst Alexanderson for General Electric to produce a workable international and submarine communication system for the Navy around the time of World War I. And that's what led to the creation of RCA, was strictly to be the keeper of the Alexanderson system.
And Jerry Vassilatos has another book, Lost Science or Lost Sciences, something
Yeah,
like that.
Lost Science has really got a really good portrayal of the work of Philo Farnsworth. Lost Science is another must-get book. But
Yeah.
the Secrets of Cold War Technology became banned, and that's why it's so expensive, because it's not continuing to be produced. That book upset some people. The same people that have created a lot of problems for me in the RCA days.
Mhm. Okay, let's see. I'll just read a couple other things real quick, and then we can go ahead and close it out. From Jenko Run, I have a final question for Eric. If a circuit could operate where the magnetic field is completely eliminated and the current composed only of longitudinal etheric flow and dielectric field potential, how could this be experimentally verified, and what effects would we expect to observe?
Well, that's how the Tesla transformers communicate between the transmitting coil and the receiving coil. But what has to be developed is the necessary instrumentation to make a determination of what fields are what and what have you. So it would be a rather difficult and novel laboratory setup to make those determinations.
Okay. Cold Electric, he says, thank you for your lifelong efforts in teaching, Eric. It's invaluable. mTOR slows aging. Yeah, mTOR pathway. This is related to some metabolic cancer stuff and aging. And okay, let's see. I'm going to skip through that. Any thoughts on Kaiser's harmonics? Would that be that book Kaiser?
Oh, Hans Kaiser.
Hans Kaiser, that's it.
That actually is a key part of my Pythagorean coordinate system work. Hans Kaiser and the guy that he was a follower of, I think his name is Timaeus or Demus or something like that. There's the Hans Kaiser Institute, I believe, still exists. The Hans Kaiser textbook of harmonics was being transcribed and ready for republishing by Jocelyn Godwin, who is the #1 authority on these subjects. In fact, I studied his writings extensively to produce my Power of the Ether as related to music and electricity. So that Hans Kaiser had developed a graphical presentation of the Pythagorean coordinate systems as applied to the more modern musical scale, which is an absolutely stunning effort and was essential to my study of and development of the Pythagorean coordinate system, which is something that's never really been completed or even started for the most part. That's some of the stuff that you photocopied or whatever you call it now from here. The text would be an inordinate quantity of labor. So what I've decided to do with that, because I basically, how I produce these things is the first thing I do is draw all the graphs and the pictures and diagrams and then write about them. I learned that from producing these presentations. That way I can get up there on stage and bark for 4 hours without any notes, keep everything together, is by stimulating my mind with the diagrams. So what I've decided to do is all the diagrams and drawings should be put out as an Amazon book. And then the text can be added later. But with a lot of these things that I've written, is everything you need to know is in the diagrams and the drawings and what have you. And I just add the text to explain it. So I completely transcribed BWV, I believe it's 536, the one we were working on that didn't get completed, into digital form. In other words, radio teletype digital, all color coded. Took me 6 months to completely transcribe it, but that one will come out by itself because there is no text with it. And it's really interesting. It's unlike using musical shorthand like musicians use, which really kind of occludes the flow of the music. This, you can see the entire working dynamics of the music as it propagates from beginning to end. And it was a massive effort. And then another one that goes with that, that's all diagrams and what have you, is the development of the Frederick Terman bandpass filter equations, which is a real journey through the relationships between transverse and longitudinal waves. The reason I did that is because I was designing the intermediate frequency bandpass filter for Griffin's seismic receiver. That took about 4 months. It was another major effort. In fact, I even had to get the help of some professional academic mathematicians to help me resolve some of that. It's probably one of the most complicated algebraic formulations in existence. So those two will be coming out as labor and time permits in their raw forms. And neither of those two, neither the Bach or the Terman, has text because they're completely self-explanatory.
Okay. All right. I guess we can go ahead and end there. There's a couple other comments, but we're going on 2 hours. It's 2:22 right now.
Well, if there's just a couple, let's see if we can squeeze them in. I'll keep it short.
Okay. The question about Kaiser's harmonics. Also asking, I'm probably going to butcher this one, but what about Leerbuch der Harmonik and acroasis?
The acroasis one is kind of it's tedious, but the textbook of harmonics is more direct. They're getting down into the actual mathematics of the situation. But in order to understand Kaiser, it is preferable to read everything he wrote to get an idea of his perspective and the words that he uses. So read whatever you can get.
Yeah, and those Jocelyn Goodwin books, those are all easy to get. Those are all on Amazon. I think they're still published, or plenty of used copies or whatever.
Well,
And
that's where I got my textbook of harmonics from, was him. He
is
sent
that
me,
what that Lair Buke is, the book of
yeah,
harmonics? Okay.
yeah. So I don't know if it's published now or what have you, but he sent me his raw transcription and diagrams and all that, which was very nice of him. I think that was
Yeah, I remember that.
through your musician friend. What was his name?
Chuck Berry.
Yeah, Chuck Berry. He set that up. So I made quite an impression on that crowd
Yeah.
with my work on the Pythagorean coordinate system. So it was reciprocated by providing me with, unfinished, or I would say unpublished texts, which of course, is proprietary. So that was for me only.
Yeah, that was, and the power of music as related to ether and electricity, right?
Yeah.
I think that was 2015. That was at the conference downtown Coeur d'Alene at the Hayden Eagles Lodge. Yeah, downtown Coeur d'Alene. Charles Rolandberry, he's a music composer in Seattle, and he has a specialty on like ancient music, something like that.
Yeah. Well, Jocelyn Godwin is the authority on what they call speculative music, which kind of goes up to the time of Rudolf Steiner and all that. But this stuff goes way, way back. So what got me started on this, well, actually was my study of Bach and pre-classical music in college, and extensive listening and what have you. And then I was given a book when I was in Lone Pine. There was a guy that would come in the coffee shop in the morning, and he'd give me these big, thick books on these kind of subjects. And he said, read this and tell me what it means. So that fueled a lot of what got written in the second half of the Lone Pine writings, which I don't know if all of that is out or not. But the book that he gave me was called, it was that Jamie Jameson, Music of the Spheres.
Mm-hmm.
And that really kind of did the shockwave, like Jerry Vaslados' Secrets of Cold War Technology, and Line's Occult Ether Physics. And so the power of the ether is related to music and electricity is based on that book. Quite typically with any presentation that I put out in the early days was based on one book or another.
And that's the presentation, which at the very end of it, Eric presents on J.J. Thomson's equations that he mentioned about the ether. That's all spelled out at the end of that power of ether as related to music and electricity presentation.
Yeah, those equations were a rather remarkable outcome, even though there's some typo errors in there, like, something's not squared that should be, or what have you. I've got to work that over again, because those equations are extremely important, because that basically quantifies in centimeter, gram, second units the substance of the ether, the electrical ether. And the whole thing about electricity, and this is why the physicists hate it and trash it ever they can, electricity is not material. It is not of this world. It's another world. And the relationship between matter and electricity was the key interest of J.J. Thomson. And he had figured out, even though it's all occluded in some really convoluted mathematics in his recent researches on electricity and magnetism, I stuck with it almost to the point of flinging the book out of the window of my car on the highway with frustration, to get those quantified and to come up with the electrical replacement for mass. And I succeeded, and I was absolutely elated. So what I have to do is go back to my notebooks here, which if you don't have those transcribed, we got to make sure that you do. because that work is critical to all this, is of the Thomson representation of the Tesla current and Thomson representation of the true corpuscle of electricity, which is not the electron. It's something else, and it is not physical.
Okay. And yeah, confirmation, the Themis name, Albert von Themis or Thymus.
Yeah,
That's the full
he's
name.
actually the one that developed most of what Hans Kaiser presents.
Okay. Let's see. Cold Electric posted a PDF in the chat of Secrets of Cold War Technology. That looks like it's on somebody's WordPress page. And just keep in mind, the book is copyrighted. It is a Jerry Vassalato still has copyrights for his works, so we want to be mindful of that. Lawrence says, okay, Bruce Cathy wrote in 1977, Tesla had found positive proof of the harmonic structure of nature. This is why I was asking about line initially.
Oh, okay. Well, I don't really have much regard for Bruce Cathy.
Yeah. Can you rotate your laptop just a couple degrees counterclockwise? Yeah, there you go. There you go. I thought you were using a 1/3 roll to look a little more cool with the.
No, I'm just roller chair, I drift.
Let's see. Jenko Run comments, you may find John Keeley work of interest. He was big on that stuff. There was also a big fraud element with John Keeley. I know some stuff behind the scenes that has never been posted public anywhere ever. There's somebody that has that information. I'd like to encourage them to actually present on it at some point. Let's see. So the Earth grid model would reconcile the virtual ground effect of TMT.
No, just stay away from the Bruce Cathy stuff.
Yeah.
It's not really. But with regard to Keeley, there's something I can point out. If I'm wrong, tell me. But I believe that's follows the same line as what's called cymatics. Do you know what that is?
So cymatics is where sound can
Standing waves. Yeah.
right. It can shape, cause shape and geometrical patterns.
So I have a brief story to relate to that gives some level of validity. I have a thing that I learned from RCA. In fact, I even have the RCA receivers here, but I don't have the 5-acre antenna put up. Needless to say, that would be a costly episode, probably about $150,000. But at any rate, I've got the right of ways and the whole thing. But at Landers, I had all that. And I had a pair of phase coherent Collins R. What were they? They were R392s, I believe. They were a small version that ran on 24 volts DC, but they were still vacuum tubes. And they were rendered coherent so that the oscillators in both were in sync. And that created an earth signal stereo receiver where I had two antennas at 90 degrees to each other, kind of like the two ears on my head. And it produced this thing that I learned about from RCA, was this earth stereo, where if you take two receivers that are phase coherent and you put up two antennas several wavelengths apart, which they called space diversity, you can hear a shortwave station somewhere else on the Earth in Earth stereo. In other words, the Earth ionosphere waveguide becomes the concert hall, and the sound is absolutely flabbergasting. It's a stereo like no one has ever heard before. I'm just itching to be able to reproduce it, but that would take a good slice of $1 million bill at this point, even though I do have the receivers. So the musical instruments of like music being played from China would float around in the room with a distinct location that you could reach out and like almost touch, and they would move depending upon what the ionosphere was doing. So there was one broadcast that came out of China every day that was used to jam other stations. China's good for that. And Chinese classical music is perfect for that because Chinese music is like almost an octave higher than Western music. It's very squeaky and it's really good for jamming stuff out, which made it hard to receive because you were picking up the station it was jamming as well as the music. So you had to fool around and find the frequency. So it came on every certain hour every day, and I'd always tune that in and turn it up full volume on the 100-watt amplifier, and it was roaring away, and the music was flying around in the room, and I had the speakers were sitting on my workbench, and I had a small headlight, motorcycle headlight, laying in the middle of the workbench that I was using as a ballast resistor for battery charging. And it was just sitting there by itself. And that music screeched out some kind of sound, and that headlight jumped about 8 inches into the air and landed back down again on the bench.
Free energy.
Something.
Okay, electron field from which electrons arise according to quantum field theory is also not material. And what was J.J. Thomson's quote about the electron itself?
Oh, let's see. Here's to the electron, may be of no use to anybody.
And he got the Nobel Prize for discovering it.
J.J. Thomson despised the modern concept of the electron. So did Gustave Le Bon. In fact, Gustave Le Bon railed against it continuously. Now, you know, a stiff academician like J.J. Thomson to come out with a statement like that, I mean, that's even more brazen than something Steinmetz would bark out. And he must have been pissed. So here's to the electron.
Okay, I guess a good time to wrap it up, and
Yeah, it's
we'll-
enough.
we'll do one of these in a few weeks. I'll announce it on Energy Times and Eric's newsletter, emediapress.com/Energy Times. If you're on that, that's where the announcements will go out, conference, these calls, when new videos comes out. So I guess with that, we'll go ahead and wrap it up, and we'll see everybody next time. Thanks for joining the call, everybody.
Always a
You guys.
pleasure.
Okay, see you guys. See you, Eric.
Okay, until
Okay,
the
talk
next
to you soon.
time.
Okay.